Right, most of us know about decimal places and so on, right? I just go over that. But the one that we tend to forget is significant figures. Okay, I want to go over the significant figures rules. All right, quickly, let's just quickly run over decimal places. Somebody write it, sir? Yeah, go ahead. Right, I want to just quickly run through decimal places. If you have 2.941, right? If you have 2.9, right? If you have 2.491 and I set to 2 decimal places, what would it be? 2 point what? So you have to look firstly. You have to look firstly at the value at the second decimal place. Okay, and then check the value after it. If the value after it is 5 or more, then you round off the 9. Okay, otherwise, if it's not, you leave it as it is. So if I said 2 decimal places, what would it be? In this case is what? 2.49. Suppose I said 1 decimal place now. Suppose I said 1 decimal place, I'll be looking at what? Right, I'm looking at the 4. If the value after the 4 is 5 or more, we round up the 4 to 5. So it becomes 2.5. That's okay? All right, just make a note right now, please. Just make a note of this one. That's one way to do it. I want to focus on significant figures and standard form. Hopefully not. Right, sorry. Right, so that's a quick little thing on decimal places. I'm gonna just make sure you catch this. Try this one to 3.578. put 2 decimal places and 1 decimal place. I know it's easy, but today's an easy class, right? .578, right? 2 decimal and 1 decimal. Wait, Anya. When you're sending your answers, right? Send your answers to the host. If you can do that, because I was watching Atelier here and you're watching all the answers. See if you can send it to the host instead. Nice, yes. Right. So I could see those there. All right, so these are some simple 1-mark questions that I don't want to give up, right? All right, let's go. What you all got for 2 decimal places? 3.58 because the number after 7 is more than 5. And 1 decimal place. 3.6 because the number after 5 is more than 8. Nice. So you're all good to go there. Now significant figures. Here's where we make mistakes. Everybody writing? No? All right, significant figures. Plenty rules. We have to make sure we understand all these rules, right? So the first rule is that all non-zero numbers are significant. I mean, we know that non-zero is like 5 and 1 and 2. All these numbers are significant. Okay? Everybody okay with that? So all non-zero numbers are significant. Next, zeros between 2 non-zero digits are significant. So see that 0 in the middle there? That 0 is significant. Everybody okay with that? So zeros between 2 non-zero digits are significant. Everybody all right? Coming to the complicated part now. Leading zeros are not significant. Right? So look at that. Look at this one here. 0.0045 only has 2 significant figures in maths. Physics is a little different, right? But in maths, 0.0045, the only significant figures there are the 4 and the 5. This 0, this 0, this 0, not considered to be significant. You all okay with that? What about here? How many significant figures we have here? How much? 1, right? Only the 2 is significant. Are you okay with that? Yeah. I'll learn some names, we. The so the pick answer at the some people to pick one there. I don't know all the names. All right, it's like this. Yeah. And then the Vanna last. So Megan. All right, I'll learn it. Take me a little while. Okay, so you're okay with that? So any leading 0, not significant. All right. Next one. Trailing zeros to the right, and here's the important thing. Decimal. Trailing zeros to the right of a decimal are significant. So you see this here? See how you have 4, 5, and you have trailing zeros, right? These are not trailing zeros because there's a 0 before it. Okay? Trailing zeros. So after the 4 and 5 and decimal place, all these values here are significant. So if I ask you, if I gave you 45.00 and I said to write this in terms of 2 significant figures, what you do is this. Write 4, 5 and leave out the decimal place. Okay? So 4, 5 is 2 significant figures. Once you put that decimal place, those other zeros become significant. All right? Trailing zeros in a whole number with decimal right? Trailing zeros with decimal as significant. Right? Trailing zeros in a whole number with a decimal as significant. That's kind of like the same thing here. And trailing zeros with no decimal are not significant. Everybody okay with that? So you have to say that decimal place is what will make them significant. All right? Yeah, one. That should be it. I hope. Nice. Well, okay with significant figures there. Right? We'll do some questions and you will practice it, right? Yeah. Let's do my favor, write down these two rules here alone. Right? Because as I said, you'll have this summary, right? But I want you to write these two rules here. 3 and 4. Right, rule 3 and 4. Right? I have two numbers there, 3200 and 3200 point with a decimal place, right? How many significant figures here? First one is how much? 2, right? No decimal place. So those two zeros on the end are not significant. That's okay? But if I put in decimal place, how many significant figures we have? 4. All right? So that's some rules I just wanted to remember. Okay? All right, so there are some other things that we need to know. You don't really see them as much in maths, right? But there are some quick rules that we need to remember, right? Commutative, Right, commutative. If you have x plus y is the same as y plus x. So all it's saying is this. If I give you 2 plus 3, that'll give you the same answer as 3 plus 2. That's okay? Same thing with your multiply. 2 multiplied by 3 is the same as 3 multiplied by 2. Okay? So if they tell you something commutative, it means that you can switch them around and work it out. All right? Quick question. 5 divided by 2. Is that commutative? No. Because 2 divided by 5 is not the same thing. Right? Only addition and multiplication commutative. All right? Associative. Right? If you have 3 things, yeah, you can do all those except this. And you, that's not all, yeah? 1 second. Right. As I was saying there, associative. Associative. So if you have 2 plus 3 plus 4, you can add here first or you can add here first. Right? That's the associative rule. Distributive is the expansion rule, basically. X by y, x by z. So if I give you something like this, you can multiply 2 by 5 and then 2 by 3. Right? Things we know already, but sometimes they might ask you, what does this represent? Right? And that's the distributive law. They'll ask you, what does this represent? That's the associative law. Most times, the popular one in maths is this one here. Commutative law. Okay? In one of the years, they even ask you what is the additive identity. Right? So that's why I add this back into the notes so you will have it. What does additive identity mean? It means that if I give you 1, right? What do you add to 1 to get back 1? Kanisha? Yeah. What do you add to 1 to get back 1? 0. So that 0 is called your additive identity. Right? Let's say you have to get the additive inverse, right? So x plus what, or let's say 1 plus what will give you 0. Minus 1, right? Minus 1 is called the additive inverse. Okay? So there's 1 year, I can't remember yet, about 3 years ago. On your phone? You on your phone there? Right? One of the years they ask you what's the additive identity, right? So you need to know those things. What about multiplication? If I give you 5, right? What do you multiply by? There's a mistake. That should be x. What do you multiply 5 by to get back 5? 1. So the multiplicative identity is 1. Are you okay with that? Yeah. What do you multiply 5 by to get 1? What do you multiply 5 by to get 1? Any guess? I'll tell you. Negative 5, no. 1 over 5. Right? 1 over 5 call the inverse of 5. Okay? It's called the multiplicative inverse. So when you flip 5 on 1 over, they get 1 on 5. All right? So watching some of you, that's the first time you'll probably hear them things in your life. Write that down. Right? It don't always come, but it's you need to know 1, 2, 3, 4. Those 4 are important. Let's see if I can blow it up a little bit there. I know it's in your handle, but still write them because it's like the first. Okay, so we have to learn all of them. Make sure you know. So what's the additive identity? 0. Right? What's the multiplicative identity? 1. Yeah. Going forward. Okay, nice. All right, let us just try a few here. Have I done? All right. So let's try June 2016. Let's try these two here, June and Jan. Notice you don't have to work it out, just put it in the calculator. If you cannot put a fraction in the calculator, come and I'll help you do it. Okay, try that in. This is June 2016, number one, and Jan 2016. And that's expanding a little bit, right? So you will recognize that you have to be able to use a calculator already. Yeah, you use the calculator properly. If you have one. Anybody cannot put a fraction in the calculator? Instead of writing 3 and 3, and put in the proper fraction, right? So put 3 by 8 is 24 and 3. Put 27 and 2, right? 27 and 2. Right? Put fraction using e instead of. Use the calculator and work out part 1, write down the value again. And imagine give it 2 marks. And I will show you later on how hard you are going to put 2 marks in the latter part. Well, what is the fraction? I got that. Right, and that's 2 marks. 2 marks for being able to use the calculator. Right? For 2 marks, again, let's put the calculator. How much you got there for the first one? 3/4. Yeah? Anybody not getting that? Jason, you getting through that? You got that?
Oh, yes, sir. Yes, sir.
I don't have. I used to have extra ones, but I think they borrow it for exams and then how many calculators? Right, go ahead, do the next 2 parts. That should be easier to put in the calculator. Right, put the next 2 parts in the calculator, 2 decimal places, so part 2, and the exact value for next part. Right, so see how it is there, put it exactly in the calculator for part 2. Okay, well, what you all got for 2 decimal places? Huh? 3.84. 3.84. And what you all got for the next one, exact value? Are you doing that? Do the next one pass? Exactly what you see, put it in the calculator, especially those sharp calculators, right? Put it exactly like that from a place. Yes, boy. And that is. Any pen? No, one that I'm not using. Otherwise, I'll get one. My pen I'm not using. Not using. Not. I'm not using it. Yeah, how much you all got for the exact value? 2.8. 2.88 for the exact value. Exact value means the whole thing, 2.88. Okay, nice. Right, 2.88. Let's go again. Let's try next one. Let's try this one here. Using a calculator, let's get those values and let's practice the one with the three significant figures. That's June 2012. I mean 14. June 2014. Again, I want to highlight how important the calculator and being able to use it is, right? And I would always advise to try to get a Casio calculator. Hey, give me the phone for now, but I need to try to get a calculator, right? Right, the first two is the exact value. The third one is, yeah, you're changing the kind of figure. So write the exact value first and then put the answer to the kind of figure, right? Part C. Oh, just got it. All right, how did this go? Right, so the first one is what? How much? For the first one, 15. What's it called? The first one? 350? 350. And next one is what? 2.55, nice. And the last one to three significant figures is 15.7. Nice. Trouble? Trouble? Everybody okay there? Any questions online?
No, sir.
All right, let's just do one more. Add two here. Let's do a standard form because I want to show you about standard form, right? Try this here. This is no here. You know here. Right? Right. Let's see how it went. Let's see how that went. What you all got for the first one? Exact value. 7/18. 8. 7/8, right? Again, you still get to use the calculator properly. And what was the exact value here? What was the exact value in part 2? 0 point. Right. So let's talk about standard form now. Standard form, right, is when you write by 10 to the power, right? But the value that goes in front of the multiply sign must be between 1 and 10. Must be. You can't have a value less than 1 or a value more than 10. So you see decimal place here? We have to move it decimal place such that that value, right, is between 1 and 10. So you're going to move it once to the right, and you will get 4.46. Can you move it 2 to the right? Can you move the decimal place 2 to the right? No, because you'll end up with 44.6. That's more than 10, right? So when you move a decimal place, the value has to be between 1 and 10. So I moved it 1 to the right and I got 4.46. If you move to the right, the power is minus. If you move to the left, the value is, the power is positive. Okay? Are you okay with that? Copy it down. Let's just try 2 more standard form before you wrap up, right? Are you finding it getting hot there? Are you finding it getting hot? No? Yeah, well, no, here though, because you're right on. Anyway, we'll fix that for next week. Right, let's just try 2 more standard forms. So remember, when you move the decimal place to the right, the power is negative. When you move it to the left, the power is positive. Okay, let's just try 2 more, right? Standard form. I try and put both of them in standard form. right? Standard form in each case, right? So remember the value to the left must be between 1 and 10. Okay. Okay, so the first one, 1, 2, 3. So we move it 3 times to the right, and we got 5.23. 3 times means -3. Okay. Here we go in 1, 2, 3, 4 times. So that'll be 5.23. We move it 4 to the left, so that'll be 10 to the power of +4. That's okay? That's standard form, right? All right. When I send you this document, I want you all to go over consumer arithmetic and a few other small things, right? Next week, I'll do a couple of questions and then we start algebra. Okay? The main focus is being able to do algebra properly. Okay? So I'll wrap up there for today.